Welcome to the first Southern Plains Climate Science Seminar Series. These seminars or webinars are a joint initiative of the South Central Climate Adaptation Science Center, the Southern Climate Impacts Planning Program, and the Southern Plains Climate Hub. If you'd like more information about these seminar series, visit www.southernClimate.org/pages/meetings and workshops. So I'm going to now turn it over to the the University Director of the South Central Climate Adaptation Science Center, Dr. Renee McPherson.
Hello, everybody. I'm excited to introduce our first speaker for this seminar series. She is a co-PI as part of the South Central Climate Adaptation Science Center and one of the most accomplished and well-known scientists working in the area of climate change. Dr. Katharine Hayhoe is an accomplished atmospheric scientist who studies climate change and why it matters to us here and now. She also is a remarkable communicator who has received the American Geophysical Union's Climate Communication Prize, the Stephen Schneider Climate Communication Award, and has been named to a number of lists, including Time Magazine's 100 Most Influential People and Fortune Magazine's World's Greatest Leaders. Katharine is currently a professor and directs the Climate Science Center at Texas Tech University. She has her Bachelor's of Science in Physics from the University of Toronto and a Master's of Science and PhD in Atmospheric Science from the University of Illinois. Thank you, Katharine, for being with us today and being our first speaker. I'll hand it over to you.
Thank you, Renee. It is great to be here. Webinar series, I think, are a fantastic idea because, first of all, it allows us all to connect live across many different states and regions in a low carbon way. And then also by recording this is a resource that will be available to anyone else that you can share with them afterwards. I'm delighted to be able to talk to you today about highlights from the 4th U.S. National Climate Assessment. And while I'm going to comment generally on some of the overarching highlights, I also want to focus in on our region, which is the Southern Great Plains. Now, when we talk about climate change, we often fixate on the number of people who agree with the science, because the science is very clear. Climate is changing and humans really are responsible. So this is a map from the Yale Climate Opinion Polls. You may be familiar with this. If not, you can find it online by just Googling Yale Climate Opinion and it will pop right up. It's a very interesting series of maps because they show public opinion by county and by congressional district. So this is asking people, do you think global warming is mostly caused by human activities? And anywhere that is blue, less than 50% of people said yes. Anywhere that is orange, it's more than 50%. And the darker the colors, the more extreme the views are in either direction. So we are in Texas Tech University, we are in Lubbock County, where 54% of people, only 3% less than the national average, would say that global warming is caused mostly by human activities. So when we look at a poll like this, we often think, if they just knew the facts, surely they change their minds, right? And the first volume of the National Climate Assessment, which came out a year ago last November, so November 2017, this first volume was the facts. You can find this online at science2017.globalchange.gov. This volume focuses on how do we know climate is changing and what's happening to our temperature, our rainfall, our droughts, storms, hurricanes, the Arctic, the oceans, and more. Volume 1 is currently the most comprehensive and up-to-date assessment of the state of climate science in the world today. It's not quite as comprehensive as an IPCC report, but it is pretty up-to-date. Like I said, it's only about a year old. It was reviewed and written by authors from 12 federal agencies. There was more than 50 of us contributing to Volume 1. It was almost 500 pages long. It was subject, as was volume 2, to a full public review where we had, as authors, had to respond to every single public comment we received, and that is a matter of public record. It was also subject to a National Academy review. The National Academy review of volume 1 was over 100 pages long. And again, volume 1 is just under 500 pages long. So the National Academy review was almost 20 to 25% the size of the document itself. And we responded to all of those comments fully, as well as 2 agency reviews. Now, even though this is about 500 pages long, we can summarize it in one sentence. It's real, it's us, it's serious, and the window of time to prevent widespread dangerous impacts is closing fast. Highlights from volume 1, in addition to talking specifically about issues like how is climate change affecting large-scale circulation and the Arctic and the oceans and sea level rise and more. Highlights include the fact that the future really is in our hands. The climate system is complex, but we humans today are in the driver's seat. Climate change beyond the next few decades depends primarily on the heat-trapping gases that we produce and the remaining uncertainty in how sensitive the Earth's climate is to this truly unprecedented experiment that we are inadvertently conducting with it. So we lay out in chapter 4, the scenarios chapter, the different pictures of the future that depend on choices we make and how those compare, for example, to paleoclimates in the past or to the global temperature targets that we often hear people talking about, like 1.5 and 2 degrees. For me, one of the most interesting chapters, frankly, was chapter 15, where we talk about the potential for surprises in the climate system. We compare what's happening today to what we know has happened in the distant past. And to really put it in perspective, when we recognize that today carbon dioxide levels have passed 400 parts per million, they've actually passed 410 parts per million now, that level last occurred about 3 million years ago, when global temperature and sea level, once they had a chance to equilibrate, which of course takes more than a few decades, once they had a chance to equilibrate to that level of carbon dioxide in the atmosphere, they were significantly higher than today. Continued growth in CO2 emissions over the century and beyond would lead to atmospheric levels we haven't seen in tens of millions of years. And perhaps most shockingly, the present day emissions rate of nearly 10 gigatons per year, which is what we humans are producing primarily through digging up and burning fossil fuels, that's about 75% of the problem. About 25% is land use change, deforestation, and agriculture, means that there's no analog for this century. In at least the last 100 million years, we have never seen this much carbon going into the atmosphere this fast. That is why it is truly an unprecedented experiment. And of course, although it has been warmer in the past, we did not have 7.5 billion people on the planet at that time. So one report that they wrote, one story that they wrote after this report came out was, do you expect this to change minds? And they asked me what I thought. I said, actually, I don't. Because if someone's not already on board with climate science, or they're disengaged and they feel like it doesn't matter, more information about the science, the social science has showed us, is not going to change their minds. In fact, in 2012, a study by Dan Kahan and colleagues that was published in Nature found that people with the highest degree of science literacy were not most concerned about climate change. Rather, they were the ones who were most polarized about it. And subsequent analysis went on to show that basically, in a nutshell, the smarter we are, the better we are at cherry picking the information and the data points that support our pre-existing views, rather than changing our minds based on what the science says. So the reality is most people don't truly have a problem with the basic science. Now, I know that sciencey sounding objections are the first things out of people's mouths. It's just a natural cycle. It's something I hear probably on a daily basis, either that or it's been warmer before. And of course I say, well, how do you know it's been warmer before? Because climate scientists have told you that. But that conversation within 30 seconds or a single tweet, almost every single time transitions from, it's just a natural cycle, it's the sun, you scientists are just making this up, to, it doesn't matter to me, or wouldn't warmer even be better? So this is a different map from the Yale Climate Opinion maps that I opened with. This map simply asks people, do you think global warming is happening? And it turns out that the vast majority of people across the country think that it is. In fact, if you have very sharp eyes, you can only find three counties in the entire country, one in Utah, one in West Virginia, and one down right on the western border of Georgia. There's only three counties where people are below 50%. The vast majority of people are well above 50%. And then you ask people, do you think it will harm plants and animals? Everybody here is over 50%, even the counties who don't think it's happening. Do you think global warming will harm future generations? Again, it is positive, medium to dark orange across the whole country. Do you think global warming will harm people in developing countries? Now we're starting to see a little bit of blue come in, but most of the country is still largely orange. Do you think global warming will harm people in the United States? It's a little bit bluer. But now the last question. Do you think global warming will harm you personally? Almost no one is over 50% here. This is the real problem. The real problem is not whether we think climate is changing or it will harm plants and animals or future generations or even people in developing countries. The real problem is we don't think it matters to us. Why? Because the number one image that we associate with climate change or global warming is that of an animal that very few of us have actually seen with our own eyes in the wild. And if we do see pictures of people, other humans who are being affected by climate change, typically those pictures are of people or places far away on low-lying islands in the South Pacific with names like Kiribati and Tuvalu that we feel like we can't even pronounce properly. So that's why I really believe that the most dangerous myth that the greatest number of us have bought into is not that science is somehow optional, though of course that is a very dangerous myth, but rather that climate change is a distant issue, that it only affects future generations or places that are far away. And that is why the second volume of the National Climate Assessment is so important. This is the volume that came out last November, the so-called Black Friday Climate Report, because it was released on the Friday after Thanksgiving. You can find it online at nca2018.globalchange.gov. And this report is essential because it brings the issue down to the places where we live. It is no longer about future generations. It is not about people who live in other countries. It is not about animals that live at the top of the world, although all of those are being disproportionately affected by a changing climate, make no mistake. The second volume of the National Climate Assessment brings it down to here. How does climate change matter to us? So volume 2 is a lot bigger. It's over 1,600 pages. And it is the most comprehensive and up-to-date assessment of how climate change is affecting the United States and how we are responding. Again, it involved authors from numerous agencies, 12 federal agencies, all kinds of authors, in fact, many who are on this call today. And because it's 1,600 pages, I can't summarize it in one sentence, but I can summarize it in 3 sentences. I think I average about 1 sentence per 500 pages. So if I was given 3 sentences, this is how I would summarize it. Climate change is not a distant issue anymore. Today, it is affecting every single one of us in every part of the US across almost every sector. And the more climate changes, the more serious and even dangerous the impacts will be. Now, if we live anywhere in the United States or the world, we know that we have heat and cold and we have wet and dry. But if we live in the Southern Great Plains in Texas or Oklahoma especially, we know that our normal climate looks more like this. Incredible extremes from heat to cold, from wet to dry, that give you whiplash on occasion. I mean, just as an example, this past August, almost 80% of the state of Texas was in drought. And then by October, we were experiencing the wettest fall on record. Where I live in Lubbock, Texas, went up against Caribou, Maine, Fairbanks, Alaska, and Fargo, North Dakota for the toughest weather city back in 2012, and Lubbock won. Now, just to even the scales, we were also part of a different competition that same year. It was a competition by a realtors association. And Lubbock also won that competition. And that competition was for the most boring city in America. Now, I don't exactly understand how we won that competition, because if you don't know somebody that well, what's the thing that you talk about the most frequently with them? The weather, of course, right? So we have more weather to talk about than almost anywhere else. But putting that aside, the point is, no matter where we live throughout our region, we are used to really extreme weather. In fact, if you look at the NOAA billion-dollar weather and climate events, the number of events that have occurred since 1980 that have caused at least $1 billion worth of damage, Texas is number one at 102 of these events, but you can see that Oklahoma, Kansas, and our larger area is also at risk. So in our region, what people often say is, why does climate change matter? Because our weather is already so extreme. In fact, we get it all. We get floods and droughts, we get ice storms and blizzards, we get devastating heat waves in the summer, wildfires, tornadoes, haboobs, hurricanes. We get pretty much everything. Why do we care about a changing climate? When it comes to climate and weather extremes, we already have a pair of dice. And rolling those double sixes is like rolling that record-breaking flood or that incredible heat wave or that devastating hurricane. If we live in the Southern Great Plains, we already have 3 sixes on our dice compared to other regions. So why do we care about a changing climate? It's because decade by decade, as the world warms, climate change is going in, so to speak, and weighting the dice against us. It's taking another one of those numbers and replacing it with a 6. And then another number replacing it with a 7. And then all of a sudden we roll a double 7 one day, like Hurricane Harvey, which had way more rainfall associated with it than we would normally expect, even for a hurricane of that size. And we say, what's happening? Why are we rolling so many double 6s and even the occasional double 7? It's because the number one way that climate change is affecting us in the places where we live, in ways that we can see it today and personally experience it and witness it, is by loading the extreme weather dice against us. Specifically, what we are seeing, for example, that heavy rainfall is becoming more intense and more frequent because warmer air holds more water vapor, and more water vapor often tends to evaporate when it's warmer. Across the United States since the 1950s, looking at the 99th percentile of rainfall here, we see a significant increase. It's greatest, of course, in the Midwest and the Northeast, but the increase that we see in our region is also quite substantial, and it is disproportionately concentrated in the eastern part of the state, which is already wetter. What concerns me as someone who works with climate models, evaluating them and looking to the future as well, is that our models tend to underestimate the observed trends, especially for the observed increase in extreme precipitation. We're seeing this across the world. Before Hurricane Harvey, Houston experienced 2 500-year flood events already in the preceding 2 years. That's what I'm talking about with double 7s. The monsoon is a normal and natural part of life in Southeast Asia, but in September 2017, a third of Bangladesh was underwater as the monsoon was supersized by warm ocean waters. Of course, most recently, we've seen incredible flooding across the Midwest, as well as around the world. Flash floods leave dozens dead in Indonesia. This phenomenon is happening around the world, but it's happening in the places where we live in ways that we can personally observe, witness, and experience the impacts of. We're also seeing that heat waves have become more frequent, and cold waves are still there. We still have winter, but they have become less frequent. In fact, in many cases, including in Texas, winter is warming faster than any other season. So we've gotten used to mild winters. And when we experience a winter that would have been average 30 or 50 years ago, everybody runs around saying, oh my goodness, it's so cold outside. How can we have this cold winter? What are you talking about with global warming? So our perception of what's cold is also changing. Now, in the National Climate Assessment, we actually have projections that look at, for example, on the right-hand side, that look at the observed change the projected change in the number of days over 100 degrees per year. And you can see this looks like significant increases. Just for perspective, Where I live in West Texas, historically, we average about 10 days per year of 100 degrees. In the summer of 2011, we had well over a month, I think somewhere around 50 days, and some places in Texas had over 75 days over 100 degrees. So we expect summers like 2011 to become much more frequent in the summer. On the left-hand side is a recent analysis that was just produced by the Associated Press a couple of weeks ago, showing that we still are breaking cold temperature records, but we're breaking them much less frequently than high temperature records. In fact, for the year of 2017, across the entire United States, for all stations, not just the ones they examined here, in 2017, we broke just over 10,000 cold temperature records around the US, but the same year, we broke well over 30,000 high temperature records. So we are seeing a shift in the ratio of cold to high temperature records. What other types of extremes? Well, droughts are a natural phenomena that dominate our climate here in the Southern Great Plains. Historical records and paleoclimate records going back centuries and even millennia show that mega droughts were a significant aspect of historical climate in our region. So we don't see droughts getting more frequent per se, but what we do see is that they get stronger because they're being enhanced by warmer temperatures. Because when a high pressure system or ridge is sitting over a region, which is one of the large scale circulation features predominantly associated with droughts, we saw this during the California drought, we saw this during the 2011 and 2012 drought over Texas. When there's a high pressure system sitting over the region, it diverts storm systems away from the region, but it's still a lot warmer. So water evaporates from our soils, our reservoirs, our streams, but it is not precipitated back down again. And so this makes the drought stronger and more intense and often prolongs them due to warmer temperatures. In fact, a recent paper that we just published this past October, so too late to make it into the National Climate Assessment, specifically looks at drought over our region. But again, this is a phenomena that we're seeing around the world. Up in the left-hand corner is a picture from the record-breaking drought in Spain last summer, where structures from the time of the Romans were exposed by dropping reservoir levels. We see drought in Texas. This is one of our reservoirs here from the drought from 2011-2012. California had a multi-year drought that just recently ended. And of course, the Syrian drought was one that was very much in the news because that was part of what contributed to driving people into the city, losing their farms, losing their properties, in part because they were not able to dig wells without permits, and permits required paying for them, often in a way that's required, bribery as well as not just the permit price. And so drought acts to exacerbate and interact with existing stressors and existing systems that are not functioning to cause significant suffering. Here in the South Central region, the paper that we just published last October showed that as climate changes, as the world warms, we expect easterly winds to become stronger. And what this does is this drives Ekman transport of ocean water northward in the Gulf of Mexico, leading to warmer water piling up along the coast. Why does this matter? It matters because we have a semi-permanent high pressure system that extends over our region in summer, and that's what leads to the midsummer dry period that occurs naturally every summer. As this high pressure system moves across our region, it will pass over the increasingly warmer water in the Gulf of Mexico, causing the system to strengthen and to be prolonged. And the stronger and more prolonged this high pressure system, the longer it directs storms away from our region, as well as suppressing convective activity over our region. And so this is a mechanism we discovered that actually creates as they call positive feedback, which is a bit of a misnomer. It's better to refer to it as a self-reinforcing feedback or even a vicious cycle, where the warmer the world is, the stronger the risk of drought over our region. And you can find this paper here. It's published in Geophysical Research Letters this past October. What other types of extremes? Well, especially more across the western part of our region in the western US, we know that wildfires are not getting more frequent, but they are burning more area. And this is part of why we see headlines like the largest wildfire on record in California last December. That record was broken by the ranch fire this past summer, and it was smashed by the Camp Fire this past fall. Why are we seeing such record-breaking wildfires? Well, wildfires are a natural part of the ecosystem in the western US. We even get wildfires here in Texas. Without climate change, it's estimated there would be an average of just over 10 million acres burned across the western US from 1980s until now. But climate change, due to hotter, drier conditions, is essentially doubling the area burned by wildfires. It's loading the dice against us. When it comes to wildfire, it has doubled the risk of rolling that double six. And then lastly, there's hurricanes. Now, again, we know that hurricanes are a natural phenomena. We call them hurricanes here. In other parts of the world, they call them cyclones or typhoons. They're tropical storms fed by warm ocean water. But we know, and this is what the first volume of the National Climate Assessment says, we know that over 90% of the extra heat that's being trapped inside the climate system by all the heat trapping gases that we are producing, that are essentially wrapping an extra blanket around the planet, trapping heat inside that would otherwise escape to space, over 90% of that heat is going into the ocean, where it can power stronger storms. So when it comes to hurricanes, despite the record-breaking season of 2017, and we have a box in the Great Plains chapter on that record-breaking season and all the attribution studies that were done related to that season, despite the record-breaking number of hurricanes in 2017, long-term, we don't see a change in the overall number because, of course, climate is the average of weather over at least 20 to 30 years. Does that mean that we don't see any impact on hurricanes at all? No, it definitely does not mean that, because we do see a number of significant impacts. We see that the rainfall associated with hurricanes is becoming more intense. Hurricane Harvey, it's estimated that 38%, almost 40% of the rain that fell during Hurricane Harvey would not have occurred if the same hurricane had happened, say 100 years ago when the world wasn't as warm. And of course, we know that 100 years ago, there was a very devastating storm, the Galveston hurricane, actually more than 100 years ago. So devastating hurricanes are nothing new, but we're seeing much more rainfall associated with those hurricanes. I mean, in some places, 50 inches of rain fell. Now, 50 inches is devastating. 30 inches is devastating too, but much less so. So there's a significant increased risk associated with storms today as opposed to 50 or 100 years ago, just because of rainfall. But then at the same time, they are intensifying faster. A study looking at how quickly hurricanes in the Gulf of Mexico and the Atlantic intensify over the last 25 years show that they're intensifying many hours faster than they used to. There's a greater number of stronger storms, same number overall, but more of them are stronger. A new study published by Jim Costin that came out just after the literature date closed for the second volume of the National Climate Assessment, his new study showed that hurricanes are moving more slowly in a warmer world, which means they can sit over us for longer and dump more rain. They are also getting bigger, and then of course there's the issue of sea level rise. So there are many ways that we personally are experiencing the impacts of a changing climate right here in the places where we live in ways that we can see and observe with our own eyes. And we're starting to witness this. We're starting to, not just as scientists, but in the public sphere, we're starting to have these discussions. An article that was published this past year said Harvey was the most significant tropical cyclone rainfall event in US history. People are starting to recognize that we're seeing some double sevens on our dice. Now, it's not just what happens here. The National Climate Assessment looks at every region and nearly every sector of the US, from water and agriculture to human health and infrastructure. For example, along the West Coast, a significant part of their rain naturally comes through atmospheric rivers, which are narrow rivers of intensely concentrated water vapor that, when they reach the coast, dump. We find that the frequency and the severity of these atmospheric rivers, which are often associated with flooding events on the West Coast, are likely to increase. Over on the other side of the country, in New England in the Northeast, we find that high tide flooding has increased significantly over the last 50 years for many small towns along the coast. High tide flooding is also known as nuisance flooding or sunny day flooding. It doesn't have to happen with a storm. It can just happen with high tide plus sea level rise. On the islands in the Pacific and the Atlantic, key infrastructure from airports to hotels to the tourism industry to very important cultural and historical sites are at risk from flooding and inundation. In the Arctic, what used to be permanently frozen ground is thawing and eroding at the same time that protective coastal sea ice, which protects the coast from very fierce autumn storms, is coming later in the year and retreating earlier in the spring. But to look at our chapter specifically, and this is what our chapter, the Southern Great Plains, looks like in the second volume of the National Climate Assessment. Our chapter does not just focus on the physical changes that we're seeing. It focuses very much on how that affects us and how we are responding. And again, it finds that we are responding, but we're just not responding fast enough. Key message 1 focuses on what they always call the food, energy, water nexus. I'm sure you've heard that phrase before. But they call it that because they really are intertwined together, and they provide the economic basis for our region. So in our chapter, it talks about how our quality of life is going to be affected by multiple stressors. We've got increasing population, we've got migration from rural to urban areas, and we've got the impact that these have on our water. This is an image of the Edwards Aquifer, one of the ones that is most sensitive to the impacts of a changing climate. And on the left-hand side, you have a figure that shows where people are already desalinating water in an attempt to provide the fresh water that we need. But of course, desalination is much more expensive than essentially free water from our aquifers underground. Key message 2 focuses on our infrastructure, how our built environment, our homes, our buildings, our roads, our transportation, our industry is at risk from increasing temperature, from more extreme precipitation, and from continued sea level rise. It isn't just the weather and the climate hazard, it's the fact that our exposure increases as our population increases, as our infrastructure increases, and our vulnerability is also increasing because our infrastructure is aging. Across the entire United States last year, the American Society of Civil Engineers graded US infrastructure, bridges, roads, highways, dams, airports, rail. It gave the majority of our infrastructure a failing grade, a C or a D or less. Rail, I think, was one of the only ones that got a B. So as our infrastructure ages and decays, it becomes even more vulnerable to changes in increasing temperature that warp rail lines, extreme precipitation that flood and erode our infrastructure, and of course, continued sea level rise as well. And on the right-hand side here, you have a map showing the areas flooded by Hurricane Harvey. But again, Hurricane Harvey was the third 500-year flood event to hit Houston in 3 years. Key message 3 focuses on ecosystems and ecosystem services. And this is a figure showing how there are winners and losers. Some species will thrive as the climate warms, but others will decline. This includes both our terrestrial and our aquatic ecosystems. They are being affected by temperature. Temperature again affects things like algae blooms in our lakes. Heavy precipitation affects the temperature of our water as well as the runoff of pollutants into our streams and reservoirs. Wildfire is also changing, and it's affecting our environment across our region. Key message 4 focuses on human health. And in a way, all of our messages are really microcosms of what we see happening around the entire country. It talks about how impacts on human health are not just related to extreme temperature, and again, these are the projected change in number of days over 100 degrees, but it's also related to things like vector-borne diseases, the spread of diseases like dengue and Zika across the United States, the impact on our water quality, the impact on the nutrition provided by our food, how extreme weather events affect us physically, they affect us socially, and increasingly we're starting to understand they even affect us mentally. They have a huge impact on our mental health. These threats are likely to increase in frequency and distribution, and they're likely to create significant economic impacts on our region. And then the last key message relates to our Indigenous peoples. Here at the South Central Climate Science and Adaptation Center, we are honored to have some of our tribal nations as full partners with us in our effort. And I really appreciate how the National Climate Assessment made a point, and especially in our region, of talking about how many of these changes disproportionately impact our Indigenous peoples. What we're looking at here is we're actually looking at a community in Louisiana that through sea level rise and through subsidence, some of that subsidence in turn due to the extraction of oil and gas and water from underground reservoirs, they are being forced to leave their homes. And so this is a picture of their community meeting where they're talking about, well, where do we go? Some of the first climate refugees in the United States are in our region. So why do we care about a changing climate? Not only because of the polar bears, because of future generations, because of plants and animals and people in developing countries, we care about a changing climate because it is taking the risks that we already face naturally in the places where we live, and it is exacerbating them, making some of them more frequent, some of them stronger or more intense, and some of them both. As the Prime Minister of the island of Dominica, which is one of the Caribbean islands that was devastated during the 2017 hurricane season, said, when he spoke to the United Nations later that fall, he said, "To deny climate change is to deny a truth that we have just lived." So while more data, more facts, more information on detection and attribution and natural forcing and human factors and ocean acidification, while more data and facts are not what we expect to change people's minds, we do see people's minds are changing. In fact, the Yale Climate Opinion Polls, which poll people regularly several times a year and have been doing so for over a decade, this past January, when their new results were published, they found the biggest increase in people's level of concern about climate change than they had ever seen in more than a decade of polling. And when they asked me this time, why are people's minds changing? I said, it's because we're starting to see these things happening in the places where we live. And through efforts like the National Climate Assessment, we are connecting the dots between the personal experiences that we are witnessing here in Texas, Louisiana, Oklahoma, New Mexico, Kansas, and more, and how a changing climate is exacerbating these or making this worse. So the National Climate Assessment, I believe, is a huge part of this effort because we are providing the frame or the understanding for people who are willing to listen of explaining why these things are happening and, even more importantly, how we can respond, both by reducing our contribution to this issue through weaning ourselves off fossil fuels as soon as possible. And our region is actually a huge leader in that. Here in Texas, we're up to 19.2% of our electricity from wind and solar as of the end of 2018. There's over 30,000 jobs in Texas alone in the clean energy industry. But we can also do so by building resilience to a changing climate, by understanding how in Houston, for example, there's a little community called Clear Lake that was already turning an old golf course into an aquatic ecosystem that was capable of storing water. They estimate that because phase one of the project was already completed before Hurricane Harvey hit, over 100 homes, I think, were saved from inundation. And they estimate when all the phases are complete, I think there's 4 or 5 phases, they will be able to save a large proportion of their community from flooding, even if Harvey occurred again. So we need to be connecting the dots between these impacts and how they're affecting us so that we can prepare for the future. Now, if you want more resources, I wanted to just let you know that our little series, Global Weirding, which some of you may be familiar with, we do it in connection with our local PBS station. It is a digital series, so it's 100% online. You can find it on YouTube. If you just Google Global Weirding on YouTube, it should pop right up. What we did was we did a new episode for every single region of the National Climate Assessment. This one right here is our region. We did the Southern Great Plains and the Southwest together. We're actually going to separate them out in the next couple months. We have a separate video for each region. But these are super short little videos that go through a lot of the key messages from each chapter, and they also give very practical examples of people who are being affected and who are responding to the impacts of a changing climate. So if you're looking for outreach resource that you'd like to share in the classroom with students, with people in the community, please feel free to use these resources. They are available. You do not have to ask permission. Just take what you need. And we also have a lot of other resources like, what's the big deal with a few degrees? What's the difference between climate and weather? Is 2 degrees a magic number? What about 1.5 degrees? We talk about all those types of things. And then lastly, I was asked to write a blog recently for PLOS, and they asked me to talk about the National Climate Assessment. So I first of all started writing the blog, talking about, what are the main messages and what are the main results from volume 1 and volume 2. But pretty soon it kind of turned into something different. So if you're interested in more of the personal side of what is it like to author the first and the second volume of the National Climate Assessment, and I'm sure many people listening have their own personal stories too, in this POLS blog that was just published earlier last month, I actually talk about what happened and how my experience started when a draft of volume 1 was leaked, so they say, to the press, and I found myself on the BBC radio at 7:30 in the morning, having had any coffee or tea, being asked, "Are you the person who leaked this draft to the New York Times?" No, what are you talking about? So it definitely has been an interesting few years, and I know many of us can speak to some of our personal stories as well. But for now, those are the highlights. I hope this has been helpful. Thank you so much for listening or for watching, and any questions that you have, we'll take them now.